thank you. Thanks for the help with the computer. Okay, a little bit about me. I'm an old geezer. I've been working in the IT industry for 30 years, which is more than many of you have been born. I started out, learned to program with punch cards, assembly language programming on single board computers. That's the very first computer I used.
Wow.
1 megahertz 6502 processor, 8 kilobytes of memory, no disk drives of any kind. It was plugged in a cassette drive. Programmed this in assembly language. Because I was an assembly language programmer, I was offered a job in the US. I came for 1 year in 1982. My boss said, "You want to go to California for a year?" I said, "Sure, why not?" That was 1982, and I never went back. I worked on what they called a word processor, which in those days wasn't software, it was actually hardware. It was basically a CPM computer, dedicated computer. Word processing software. I later moved on to a company where we did porting of Unix to various operating systems, to various computers. Most of the companies no longer exist, Data General, Prime, people like that. But we did do Unix ports to Intel processors. We actually ported Unix to the very first IBM PC, the XT, 4 megahertz, 10 megabyte disk. And that later led to us being bought by Sun Microsystems because Bob McNeely figured that he thought PCs were toys, not like Spark systems, but he wanted to hedge his bets. So he said we'd better just have Solaris on Intel boxes in our back pocket just in case. So he bought the company. I worked at Sun Microsystems for many years doing porting Solaris to Intel systems. I then moved on to more Unix development work and eventually moved into the Java group where I was responsible for developing the performance test suite, the TCK for Java SE. My family is Irish. I was born in England. I live in the US. I'm married to a Turkish lady, so I'm all kind of mixed up. And I'm very glad to be back here. This is my 3rd year in Morocco. I hope I will be able to come every year. Okay, so I know I'm going to talk about the future, but I'm going to start by going back to the past. And the reason is that, as Confucius said, if you want to make the future, you have to understand the past. You have to understand where you've come from if you want to know where you're going to go. So this is going to be a history lesson because I used to be a history professor before I became a computer geek, but hopefully you will find it interesting and maybe a little bit amusing. Stand here so I can actually see my own slides. So, history. In the beginning, standards. The very first standard was human language. Humpty Dumpty said, "Words mean whatever I want them to mean." Alice said, "That's crazy, because if that's the case, then we can't talk to each other." So the first thing we had to agree on was what words meant and how we could actually communicate with each other. We then learned to actually create symbols to write down words so we could preserve language over time, very important. We learned to create a number system, another form of standard. Currency, very important. Invented very early on as a means of exchange. Otherwise, if I've got a donkey and you have some wheat and we want to exchange, but you don't want a donkey, then we need something in between. So people invented currency. But in the early days, they were all precious metals, and people would actually, see this one here? People would take a little pair of clippers and they'd snip around the edges, so gradually the currency became debased. This was a serious problem in England in the 17th, 18th century. I'm sure you know the name Isaac Newton. He was not only a wonderful physicist and an alchemist, but he was master of the mint. They made him the guy responsible for looking after the English currency. And they were so serious about the problems of people debasing the coinage that they introduced the death penalty. Not just the death penalty, but you could be, and you were, hung, drawn, and quartered if you were caught debasing the currency. So in other words, they'd hand you, take you down, take out your guts, cut you into pieces, and then take the pieces and stick them on sticks around London. And Isaac Newton did that because the currency was so important as a standard that the state said, if you violate this, we will kill you. And that may seem like it happened a long time ago, but you may remember in China a few years ago lots of stories about debasement of food and drugs and so on. The Chinese executed the man who was responsible for maintaining the standards of drugs and food purity in China. So some standards are really important, and if you violate them, you will die. So I thought maybe we should introduce that in the software world. If you create a browser that doesn't conform to the appropriate W3C standards, maybe we should hang you, but nobody's taken me up on this yet. We learned to measure time. We learned to measure space. This is Galileo showing off his telescope. He discovered the moons of Jupiter. Once we knew that, we could learn how to navigate, we could learn how to create maps, we could wander the world. Weights and measures, very important, of course, very early form of standard. This is a measure of distance. There's something called a rod, which is about 16 feet in distance. Still in use occasionally. Germany in the 16th century, this is a kind of satirical thing, but what they said, well, what we'll do is we'll go to church, we'll take the first 16 guys who come out of church, we'll measure the length of their feet, and that will be how long we call this measure of the rod. Today we're a little more sophisticated. We measure distance in terms of, we used to do it in terms of a physical platinum bar, which was kept in France, but now they do it in terms of the speed of light and vibration of atoms and stuff like that. I came from Antwerp. In Antwerp you have guilds, which were associations of people craftspeople, who were very careful not only to protect themselves, so there was a limit to the number of people who could be goldsmiths like this guy or whatever, but also to make sure that the stuff they produced met certain standards. So they would have a hallmark, which is a way of saying this is genuine, this is appropriate, this reaches a certain standard. Printing, very important. Before the printing press was invented, there was no standard way of actually even writing down words. The spelling was all different. Printing, of course, enabled us to distribute ideas, and ideas are very dangerous, and we all know that. There are other kinds of standards. I talked about the Chinese guys. Food and drink, drugs, health, and safety. So these are areas where states, where the government steps in and sets certain requirements and says, you can't sell food that is adulterated. If you're going to have a ship or an aeroplane, it must meet certain standards and so on for the health and the safety of the population. Moving on to modern times, industry wouldn't exist if we didn't have a framework of rules and regulations around how to create corporations, how to do accounting, and so on and so on. So early joint stock companies were the earliest forms of corporations. Moving into the machine age, we had to learn how to precisely cut and shape things. We invented all of these machines that enabled us to create parts that would actually fit together. You may think screws and threads are a pretty simple idea, but in the early days, these were all, every machine shop would create their own. There was a guy called Whitworth in England, defined standards for the angles and the shapes and so on, so that things could fit together appropriately. This enabled us to build machines, which would obviously led to the railways, for example. Everybody thinks of railways as the standard of the width of the rails, but much more interesting to me is railways were responsible for standardizing time. Before the railways, every place in, I'm going to speak for England because that's where I came from, but every village had its own time. When the sun was directly overhead, that was noon. And if you moved east and west, you moved east by 17 miles or so, you're off by 1 minute. It didn't matter if the only way you can travel is by foot or by horse, because in a day you can't go far enough that you get thrown off. Today, of course, we fly in airplanes and we understand we have time zones and so on, but in those days, trying to put together a railway timetable for stuff that went east and west was completely insane, because you didn't know whether you had the starting time, the ending time, the time in the middle. The railway company said we have to have a standard form of time. They introduced it in England in the 1850s, in the US in the 1870s, and elsewhere shortly after that. This all comes down to interchangeable parts. There was a guy called Eli Whitney, created the cotton gin, which was the thing for kindling seeds out of cotton. But in the US, shortly after the revolution, he went to the US government and said, I want a contract for 10,000 muskets. The biggest contract ever awarded in the US. And he said, instead of having these things made of pieces that were created by hand, I'm going to create them machine-made. They're interchangeable. And he claimed to have demonstrated this. He had a big collection of parts, random parts, he said, and he put them all together and created a musket. Turns out he was actually lying. did not do that. These parts were actually handmade, but nevertheless he convinced the US government that he could make them by the machines, that the parts were interchangeable, and he was responsible, if not for actually doing this, but for introducing the idea of machine-made pieces that were interchangeable. This led to mass production. This is Henry Ford's assembly line Model T, and so on. Okay, let's move into the computer age. One of the first computers, Blaise Pascal, mechanical calculator. There's another one, Leibniz, the philosopher, built on that and created this beautiful device. Leibniz and Newton were big rivals. They both claimed to have invented the calculus. Newton got there first, Leibniz created the notation. Jacquard loom for weaving. This is Monsieur Jacquard, who's demonstrating his system to Napoleon. Punch cards. This was the very first use of punch cards. This is a weaving. This was weaved on his loom. It took, 24,000 punch cards to create this. There are a few of these in existence. People thought they were portraits. They were so finely created. But this showed what you could do with punch cards. As I said, I started, very first programming I ever did, we used punch cards. You had this big machine and blah, blah, blah. You had this stack of things. You take them somewhere. You wait several hours. You miss a comma or whatever. Then you have to start it over again. This computer was never actually built. This is Charles Babbage's difference engine. This was programmed via punch cards. He owned one of those weavings from Jacquard. There's a punch card reader for programming it. You turn the handle to kind of crank it. It had a printer. You can actually see this if you go to London, in the Science Museum. They have a copy of this. They built this. He never finished it because he was not much of a businessman. But on the 200th anniversary of his birth in England, the Science Museum guys said, let's see if we can build it. They took his blueprints. They found 2 small bugs in the blueprints, but otherwise they built this thing. It exists, it works. You can see it in the Science Museum, or also if you go to the US and the Computer History Museum in Manchester. Ada Lovelace, the first programmer, was a buddy of Charles Babbage's. She wrote a long appendix to a description that was published of his machine, in which she basically laid out the first computer program for generating numbers. So she was the first programmer. It's good to see so many women at this conference. I always like to promote her. She has, of course, a programming language named after her. Ada was used by the Department of Defense. Let's move on a little. Alan Turing, you've all heard of him, during the Second World War, responsible for breaking the Germans' Enigma code with this complex mechanical device. But he was more famous for inventing the notion of a Turing machine, which is a universal programmable machine. Ada Lovelace was the one who recognized that this machine was not, he built it or intended to build it just for calculating positions of the stars for navigation. He didn't realize that it could be universally programmable. She did. She said, these machines, if we create them correctly, they can be programmed to perform any kind of calculation. That was what Turing said. Of course, now we use the term Turing machine for any machine which is universally programmable. Come on to electricity. This is Tesla. One of the very first standards wars was Tesla versus Edison. Do we want direct current or alternating current? Led to the invention of the telegraph, telephone, telecommunications, and so on. Okay, so standards, though, are not all about mechanical stuff and so on. You have standards in the real world. Beer. Governments like to tax. Governments like to tax alcohol. But how do you know what is beer? If you have a brown liquid in a glass, is it beer or is it not? The National Institute of Standards and Technology in the US was asked to create a device for measuring the amount of alcohol in beer. They did so. They were also asked to define standards for ladies' clothing, so that when you went to an early clothing store, department store, which were just beginning to be introduced, you could actually have some chance that you would take something off the shelf and it would fit. Chocolate. What is chocolate? There is a World Health Organization definition for chocolate that specifies the amount of butterfat, the amount of cocoa that it must contain. Music. Music wouldn't exist if we couldn't agree on the notes, otherwise no orchestra could actually function. So there is an ISO standard for defining, I think it's the G above middle C, in terms of the vibration. What's red, what's blue, is a standard for colors. If I was using the official Oracle presentation template, there would be red background. Oracle has an official version of red, and if you don't use exactly that one with the right RGB values, Oracle's marketing guys will come after you. Traffic in this city is insane because we don't seem to agree on how to drive and where to drive and so on. But if you don't do that, everything clogs up. So you need standards there. Shipping. Before the invention of the shipping container, you had to ship goods by manually putting them in big baskets and loading them and unloading them. It took forever. Someone said, let's just create these standard-sized boxes. We can put them on ships and on trains and so on. And that's why you can buy stuff from China cheaper than you could buy from 200 miles down the road. This is like the internet for physical goods. It's packet switching with physical stuff as opposed to information. Sport, we didn't agree on the rules of the game, then you have no game. So we have FIFA defines the standard for football. Medicine, there's a World Health Organization book which is several thousand pages long that has horrible definitions and precise numbers for everything that could possibly be wrong. I was in the dentist several years ago and I saw a little note on the dentist thing and it said, please set teeth shade A3. There was like a mold that they take. And of course, if you think about it, false teeth have got to match color in your existing ones. So there is a standard for the actual color of the teeth and it's done by reflective something or other. I don't understand the technology, but you have standards for teeth too. Barcodes, ISBN numbers, home entertainment, HD DVD lost out to Blu-ray, which is good because Blu-ray has Java in it. MP3, encoding of audio files, standards. What happens if you don't have standards? Here's one example. Baltimore, 1904, fire broke out in the central business district. All the towns around sent their fire engines in to help. They got there, they took out their hoses, and they couldn't attach them to the fire hydrants because there was no standard for the coupling. So, 1/3 of the business district burned down, cost $150 million to replace it. That was real money in 1904. Not good. After that, they said, it might be a good idea if we had a standard for screws and threads. Remember that? 1999, Mars Orbiter. They did all the way to Mars, then they did the final burn, and instead of going into orbit, it crashed down into the planet. Because the software and the hardware for operating the thrusters, one was operating on metric measurements and one was operating on imperial measurements. No agreement on the standards, wasted the entire voyage. So what is this all about? $64,000 question. Are we artisans? We call ourselves engineers. We're not engineers. Engineers build bridges. Bridges stay up. Okay? We build software. Software breaks. It's more fun to do stuff this way. I used to do woodwork when I was young. It's great. You do things by hand. They don't fit. You can kludge it. It's creative, but it's not engineering. Engineering is when you take well-defined blueprints and take things off the shelf and bolt them together. It's not creative. It's not fun. The damn things stay up. Okay? So we've got to learn to be engineers. We are not engineers, but we're getting there, maybe. It's all about standards. Standards make the world go round, as I've said. What we mean by a standard is an agreed-upon way of doing something makes human activity more efficient or more productive. Some of them are what we call de facto. They just become a standard because somebody puts something out there and people say this is useful and people adopt it. Windows is like that. Microsoft Office and stuff like that. Adobe PDF was a de facto standard. They later formally standardized it, but in the early days it wasn't. De jure standards were developed through a formal process through some kind of organization. There are two kinds of organizations. You have national and international bodies like ANSI and ITU, and then you have what we call consortiums, such as W3C or OASIS or the JCP. Open standards. Standards are not much use if they're not open. If they're not created through a formal process of collaboration, anybody can participate, level playing field, so nobody's particularly dominant, and the way stuff is done is well understood and documented, and everybody can implement them. Open source is good, but it's not a substitute for open standards. If all you have is the source code and there is no standard underlying it, it's not that different from proprietary stuff. If you're very, very rich, you may be able to afford to fork that source and maintain it yourself, and to backport your patches to the original mainline, or retake from the mainline and reintegrate. But most people can't do that. So effectively you're locked in. What's really important is that you must be possible to create multiple implementations of something. And you can't do that if you don't have a formal specification for what that something is. Facebook, big users of PHP, they decided a couple of years ago that the default implementation wasn't fast enough, wasn't efficient enough for them. They said they'd create their own version. Then they realized they couldn't, because there's no definition for how PHP should work. There is an implementation, you can copy that implementation, but you don't know whether you're copying its bugs, whatever. So they said the first thing we've got to do is define a formal specification for the PHP language, and they said they would do that last year. If people are building big systems, they're going to want a choice of implementations, and they're going to want to build on top of standards. We'll call this eliminating vendor lock-in. You're not locked into a particular supplier. In the early days, you bought a computer from IBM, that was it. They owned you for life. Okay, you had to buy the hardware from them, you had to buy the software from them, you had to buy the documentation from them, the peripherals from them, the training from them, because nobody else's stuff would work. Today, we can mix and match, right? This didn't plug in, this one did. I took my USB stick, stuck it in here, everything works because we have standards. We have choice, we can mix and match. Open source and open standards complement each other. It's a very good idea to implement standards in open source, because then more people will adopt them. And it's also a good idea to actually, before you standardize something, to actually develop it interactively with a bunch of other people through some kind of open source project. So, industrial strength, I've lost a couple of pictures here. Industrial strength systems built on top of standards. Whoa! Okay, I lost more pictures there, never mind. What the hell is going on here? What? Sorry. If this is working, let's see if it works for me now. Nope. That's a shame. Sorry about this. I have to recopy the file. Come back. Sorry, give me a moment. I don't usually have these problems. It's all about software interoperability, as I said, mixing and matching. We care about languages and protocols. This is the Tower of Babel. In the early days, human beings were all one big happy family, and they decided for some bizarre reason to build this big tower up into the sky, and God said, no, you're getting too big for your boots. He decided to punish them, and the way he punished them was to knock down their tower and divide them into groups of people who could not understand each other, who spoke different languages. We have to agree on languages so our computers and our system can talk to each other. We care about interfaces, the way that software plugs together. When I started way back on that little dinky little machine, there was no libraries of any kind. If you wanted to read input, you had to actually go into the hardware and look at the particular locations where the keyboard values are stored and so on. Today you can just mix and match and plug things in because we agree on the way things talk to each other. Okay, talked about this. It's all about specifications, which are kind of like a legal book or a blueprint. For example, the specification for how something should operate. This is a helicopter blueprint. The way it operates is there's an anti-gravity machine that makes it go up and down. Guess what? That's a worthless standard because it's not implementable. The way we test that is we have certification processes to verify that things meet the requirements. Open source, multiple implementations, don't know that, blah, blah, blah. This is all mixed up. Okay, so Java. Okay. With Windows, what you get is what you get. Microsoft says, this is it, that's it. That's not the way Java works. We create our stuff collaboratively through the JCP. We create these things we call JSRs, Java Specification Request, which is a particular specification for a particular piece of Java technology. And this is done collaboratively. It's not just Oracle. Oracle's big competitors, IBM, HP, Red Hat, and so on, all participate in this process of developing Java together. Even though they compete very fiercely in the market with their implementations, they agree that the simplest way for this to operate is we all agree to create base stuff. We have also open source organizations, Java user groups, individual developers, all participating in this process. Don't have to go into the details here, but the point is that for each of the three platforms, Java SE, Java ME, and Java EE, there are these well-defined pieces, and the interfaces between them are defined by formal specifications, JSRs. And we do this by having a member of the Java community we call the spec lead, gathers a bunch of people who are interested, we call an expert group, and together they work on defining a new or a revision of an existing technology. And they have to produce not just the spec, but two other things. They have to produce an implementation of the specification, which we call a reference implementation. It must be complete, and it must be compatible. The way we test that it's compatible is we have a formal test suite called the Technology Compatibility Kit, and you build each of these three things together. By creating a reference implementation, you find whether the spec is actually implementable, whether there's ambiguous language in it, or whatever. When you create the tests and run them against the implementation, you find bugs in the test and bugs in the implementation. And when you actually write the tests, as you know, when you write tests against something that is supposed to be specified, you may find the language is ambiguous and you may have to tweak the spec. So these all kind of work together. Compatibility or conformance testing is at the heart of everything. We insist that all the Java implementations meet the requirements and pass the test suite. And when they do, we give them a standard of approval, like the hallmark, which is the Java seal of approval. I'm the chairperson. We have an executive committee, which is like the board of directors. We have a small administrative staff. The work is done by these expert groups led by spec leads, and the members can participate and comment and so on. Nothing much here. I've said all that. Executive committee has two responsibilities. One is to vote on GSRs as they go through the process and to supervise that process. And the other is to define how we operate. So they define the process whereby the JCP does its work. We've got 25 members. Don't need to go into the detail. Here are the members. You see we've got a mixture of big companies and small companies and individuals and Java user groups. Oh, this is an old slide. Morocco Jug is no longer on, sorry. But we do have two Java user groups who are on the executive committee, London Java Community and SoJava from Brazil. I don't need to go into those. Membership is about 3/4 individual, half in North America, 1/3 in Europe, and and the Far East, 30% in Asia, and Middle East and Africa I should include there, and a small number from South America. We have a formal process. I won't go into the details. It's all documented in this process document, but there are formal stages of submission and review and voting. And we have a formal definition of how we operate, which I call our constitution. There are two documents, a legal document called the JSPA, which is all about intellectual property rights, and the process document, which is all about how things operate and how the organization is structured. And we modify these documents by, to revise them, we use the formal process itself. We file a JSR and we create new versions of these documents. We've done 3 JSRs over the last few years, 4, to change the way we operate. The first one said, no more smoke-filled rooms. An expert group must do their work out in the open. They must have public issue trackers, public mailing lists. They must respond to comments from the public. This was very popular. It resulted in a significant increase in developer participation, particularly through Java user groups. It created something called the Adopt a JSR program, which I'll say more about later. The second JSR simply merged 2 executive committees. I won't go into details there. That was an easy one. The third one was big and scary, is big and scary. We're still working on it. We're modifying the JSPA. We haven't touched this in years. It's like legacy code. You've got to be really careful with legal documents. You don't know why some words are there. You change them, you may break it. So we've got to be very careful. Plus, it's legal. All the lawyers from each of the executive committee members, IBM and HP and so on, are all involved. Therefore, it takes forever. It matters because we care about intellectual property. We make sure that when people contribute stuff, we have the right to use it. Really? Okay, I'll go very fast. Okay, so we're working on that. I'll skip all this. Okay, because we realized that would take forever, we introduced another JSR to introduce some changes in the membership process to make it easier for individuals to join. So this is going to happen very soon. You'll be able to join as an individual without asking permission from your employer, and you'll be able to get formal recognition if you actually contribute to a JSR. The result of all this is we've made it easy for people to participate. We want this to be a real community process. We want people to get involved. Corporations can get involved. Java user groups can get involved. Individuals used to join as individuals, but you would then isolate if you didn't know what to do. We figured, okay, join through your Java user group. You can work with other people. You can help each other. It's easy to join. We have a whole bunch of Java user groups who are members of the JCP. We have 2, not 3, this is an old presentation, on the executive committee. And those 2 Java user groups run a Java community, and so Java created this process called Adopt a JSR, whereby Java user groups can say, I'm interested in a particular technology. They will get together, they will discuss it, they will help out in a number of ways. There are many ways that you can help. You don't have to be a super expert in order to help out. You can just read the spec and comment on it. And if you don't understand it, that's not your fault. That's the fault of the guys who wrote it, because we are writing the stuff for 10 million developers, not for a handful of experts. So as regular developers, if you don't understand, or if you find a spec difficult to use or an API confusing, that's a bad design. You provide the feedback, the spec lead and the expert group will be very glad to hear about it. And we want you to do this not because it's out of charity, but because it's good for your career. You're all smart people, we know that, but if you want to really get on, in addition to technical skills, you need soft skills, communication skills, negotiation, collaboration, teamwork. These are the kind of things that you learn by participating in open source projects or in the development of standards through the JCP. As I said, there's a whole number of things you can do, from simple stuff like helping with bugs and documentation and giving short talks, to more complicated things like actually creating implementations that test out some of the new APIs, developing test suites and so on. We have a big international effort. We have a whole bunch of user groups, including a number from Africa, who've helped with Java EE and are helping today with the next version of Java EE and the next version of Java SE. Here are some of them, including African guys. I know the Morocco guys have worked on some stuff also. Okay, blah, blah, blah. 2 other ways you can participate. If you're more interested in the implementation, you can work on OpenJDK, which is the implementation of Java SE, open source project, or Project Glassfish, which is the open source implementation of Java E. So, plenty of ways to help. If you care about the future of Java, you want to be influential. Java's 20 years old this year. I hope it will still be around in the 25th century, maybe not that long. But whatever it is in the future, it will be because of people like you who actually have the opportunity, unlike with Windows and almost everything else, to work with everybody else in the Java community to decide what the future of Java will look like. So, join us, have fun. Thank you. We're out of time.